Welcome to Technical Training with Teacher
Successfully
Dixon.
done this using isometric method, the next thing that we have to do is to bring about the orthographic projections or orthographic views of this particular object. Alright, if you take a look at the object, okay, the first and foremost, let me talk about what is orthography. Orthography just means the representation of this pictorial diagram, which is a three-dimensional object using two dimensions. So we are going to produce this face, produce this face, produce this face. A typical three-dimensional shape has three faces. So we have, like it is shown using the arrow, this is the front view, and we have what we call the plan, that's any side you view from the top. Then we have the end view, any side you view from, the end view, that's the side. Okay, so we are going to see, if you stand by the position of this arrow and you look at this diagram, what do you see? For me, I can see this face and this. That's just for the front view. If you're standing upwards, that's from the plan view. To view this object, what we see? I will see this, and see this. Okay? And then if I am to stand by the end view to look at the object, I'll equally see this and this. So, in essence, we can say that these faces we represent by the initial. So this is end view and this is end view. Okay, this is plan and this is plan. This is equally plan. Take note of the points I've marked. And then from the front view, this is front, and this is front. So the whole of this is front view, or our front view rather. So you take note of what I've just done here. Okay, so now if you look at the front, what do you see? The diagram I'm going to see will look like this. Look at it here, and here. So it looks like that. Maybe we can equally represent using the letters that are assigned to each side. So this is B, C, D, E. B, C, D, E. And then we have F, G, H, A. F, G, H, A. Alright, so that is for the front view. That's what we will have when we go to the orthography. So just take note of that one. Now let's see what will happen in the plan. Remember, this is P, E, and E. So plan will just look somewhat like this. We have this face, and this face. So these faces will just be divided into three. So we have this, and this. This. Right? So this can be front. And this is plan. We can equally assign the letters to them, just like we've done here. And then the end view will look somewhat like this. This is NN. So it will look somewhat like this. Because you're only seeing this and this. So that's how it is going to look like. Alright, now the bottom line on this, the cause of this matter is that we are going to see how we can do this in a draftsmanship way, that is in a technical drawing way, where we use the tools that are needed in drawing board, the T-square, the set-square, and everything will be required. But before we go into that, we will first and foremost look at what we call the third angle projection. The ones we use typically in Nigeria are the phase and the third angle. We do not use the second angle here. So those are the two that we want to basically take a look at what we will do. But then, first and foremost, we want to use a third angle projection. Now, take note of what I'm going to say now. When you are doing third angle projection, this is what you have. We divide the planes into four. We have 1, 2, 3, 4. Giving us 360. So each of these is 90 degrees. other. Alright? So having done that, it is a norm for us to understand that when you are drawing in third angle projection, that the plan comes by the top left, while the front comes by the down left, and the end will come by the right, by the top right. Then this particular phase, nothing is coming here. We'll only use a 45 degrees set square to bisect this angle, thereby projecting the lines from this particular angle. So that is what we're going to do. That means, in essence, this front will come here. This is front, and this plan will come here, while the end view will come here. So we want to see, in a real practical sense, how we can achieve the look on this. So we are right now going to the drawing board. I'd like you to join me and be patient with me, because it will take a little time, though not much. So we'll work this out together and see how we can study. Do not forget that this is just, let me use it. This is just the just concluded examination, practical examination for junior secondary certificate examination. They made use of this typical diagram, so it's not far-fetched. We want to see how we can equally make use of this to produce what we are looking for. I remain your humble teacher, Teacher Dixon, the technical drawing teacher. Thank you. Let's work this out. Okay, viewers, here we are on the drawing board. So we want to take a look at how we can have these are the diagrams drawn facing each other, but we will take a deeper and keen look into this particular one, because everything we require is here. Right, like we've done already on the board, that's on the marker board. That is the same thing we want to bring practically using the drawing board format. Okay, so the first thing to be done is for you to draw the planes where the faces are to be situated. So to start doing that, you will draw using the T-square, a straight horizontal line, just like this. Ensure that the horizontal line is almost central to the page you are drawing on. Okay, so having done that, the next thing you do is to draw a vertical line to bisect or to cross that horizontal line just drawn. How to do that is this: using your set square, make it to sit squarely on the T-square. All right, we've just done that now. Okay, so we've just done that, and the next thing we require to do now is to mark 10 mm out from each of the sides. So from here to here, 10 mm, from here to here, 10 mm. Now from here to here, 10 mm, here to here, 10 mm. So I fixed dots there. Now you will draw fence lines to cross those dotted positions or to pass through. Now this is what I've just done. Okay, I've drawn that one. This is another dot that was made. I go to that point and I draw my horizontal fence line. Remember, those ones are to be fenced for now. Now I follow the ones that are supposed to be vertically drawn. The dot, following the dot, receive that upwards. Same thing to this, take it upwards. Okay, so having done that now, the next thing we are required to do, is to go to the plane of the projection, which is the right down corner, and bisect the angle. Remember I said on the board that was angle 90. So to bisect this, we use 45 degrees set square and divide the 90, which by default is going to give us 45 degrees. So I'm trying to get that done now. All right, so I've just done that. Now we have, remember, in third angle projection, like I said, this has to do with third angle projection. And I said that when you are doing third angle projection, that the plan will come here, while the front view will come here, then the end will come here. So now, remember, we'd already said that the plan looks like, when you see this point, see this, and see this. Of course, we drew that on the board. So for you to do that, you will take the measurements. This is for the plan between here, 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 and here. So that's what we are going to do now. So starting from this point, we're going to measure the length of the plan. That is between H and I. So it will go upwards. And that surface is 50 mm. Look at it here, 50. So we are going to do that now, practically. So we'll measure 50 mm. 1, 2, 3, 4, 5. Fix a point there. And we'll take our T-square to that point and draw a horizontal faint line to pass through that point to the right. Okay, so we just achieve that. The next thing we'll do is to mark the width of the plan. The width is between H and C, covering this. So by virtue, we want to say it is HG, FE, and then DC. So how do we do that? We'll take the full length first. Full length is 60. So we'll take 60 mm. That will be on the horizontal plane. So let's count. This is the position 1, 2, 3, 4, 5, 6. We'll fix a dot here. And we will draw a vertical line using the set square to pass through that point downwards. Remember, I still fence for now. Okay, so that is it. Having done that now, we are to take a look at, still consider the diagram before you take any action. We are to take a look at this first. We have, okay, let me just give the letters so that you will not forget. At this point, this is the C position. This is H position. This particular point you've not seen, let's call that, what was the last, let's call that N. So this is N position and this is I position, giving us a square object there. Now we want to take a look at the diagram from C and D, and the measurement is 20 mm. Remember, the 60 is divided into 3, 20, 20, 20. So that is exactly what we're going to do now. So 2 cm from here to here is 2, then another 2. Like so doing, we can say that can boldly make vertical lines from the just made points. We can equally draw that downwards in case, because of the projection. Remember, this is meant for projection purpose. Okay, so we've just done that. Look at the diagram again. You will see with me that this is CD. So CD, D is here. Now, this will be G, but being that it is up, it's not at this point, so it will be FE. So we can equally call this D, E as well, because it's in the same line, the same plane. Why we can call F G as well. So let's say that this is G in this diagram, since this is D, right? Okay, now having done that, we finish. Going to this side, we have here LM. So this is L rather, and M. The next thing for you to do is just to bolden the points that the diagram is to be made vivid. Okay, so, and that's exactly what I'm doing now. Making bold the points of attention, or call it points of emphasis. Okay, so we've had our plan well constructed. The next view we want to take a look at, so I can call this plan, remember? The next view we are to consider now will be the front view. The front view. Remember, the front view comes down the elevation where we have the plan. So it will be by the left down corner, which is this particular position. So having already sent down projection lines from the plan, it will not be difficult. It's for us to take a look at how the front view is, which is this particular surface. Okay, so, and then we will start from the up. Okay, so we have this point E, C, B. So we will start from there. Calling this point, we'll call this point this point will be E, while this point is F. So from there, we'll measure, because this is the tallest position, measure from there downwards. Between E and D is 20 mm as well. So we'll measure 20 from that point and fix a point here. This between C and B is also 20, so we'll fix another point where we have 20. 1, 2. Then we can make horizontal lines to match those points. And ensure that the horizontal line touches the line that bisected the other plane, which is at 45 degrees. So that's exactly what I've just done. Now this one does not give us a big challenge because we've already had the projection vertically. So we're just to draw the horizontal part. And merely looking at the diagram, we can detect that we have the phase already. That is, if you want to consider, if this is a EF and we have EF here already, it means from here to here will be from here to here, which is GH, and this will be DC, which is DC, CB, then AB, which will be AB, and AH, which will be AH. So just what I've said now, AH is here. I'll just write here B, right here A, here H, here C, then here D and G. We've got the diagram already. It's just to retrace and thicken the position so that it will be obvious to the eyes. Okay, so I'm using thick continuous lines now. Remember, when you were taught types of lines, we said that thick continuous lines are used for outlines, visible outlines. So that is exactly what I'm doing. I'm trying to make the point of emphasis visible, and by so doing, I'm making use of thick continuous lines. All right, so looking at that, we have the plan and the front view already. So you can call this front. So the next one we are left to do now is the end view. Remember, we've already projected lines here, and we've projected another line to meet these ones. So the next thing we'll do is to use the set square and the t-square, stop the t-square very well, then transfer the point on this particular line upwards, where the horizontal line touches this bisector. Take it up. Okay, so that is done. Another one is here. Equally take this up. This one has been taken up already. So we finished the drawing already. Remember, the end view is this and this and this. Okay, so we've already had that, this and this. So we can say that the end view we have AHGF. So this is the point AJ. Okay, and then we have I here, then we have H here, we have, this is K but in the position of I, so we leave that. We have L here, and we have F here. By so doing, we've just finished. It's just to make it obvious. You see, there's no need for measurement again in this particular one. We just projected the lines. Have you seen? So that's why we call this orthographic projection. At some point in the drawing, we didn't need to take measurement again. We just projected the lines. That's why this is very, very unique and important for all of us in the technical field and engineering and basic technology to be conversant with this. So this is the end view. All right, so looking at it, we've been able to achieve what we were asked to do, which is the production of the orthographic views of this particular object. This particular object, or you call it block, isometric block, where you have the front view here, the plan here, and then the end view here. So look at how the front view looks, and exactly is what you have in here. Look at how the plan is 1, 2, 3 faces, 1, 2, 3, and then the end view 1, 2, and this is 1, 2. So we've been able to achieve this in a more simplified but unique way. A more simplified but unique way. So I'd like you to maybe ask questions where you feel you're challenged in the course of this my construction. If you have any challenge, ask questions. Otherwise, do well to give a thumbs up, like, share, and comment on this. Thank you very much. I remain your humble teacher, Teacher Dixon, technical drawing teacher. See you in our next video.